ये कंप्लीट में नहीं है ना, ऐसे रहेगा ना। ठीक ठीक। गुड आफ्टरनून बच्चों, गुड आफ्टरनून। हाउ आर यू? लक्ष्मी बेटा, गुड आफ्टरनून। Am I audible to all? Please reply, beta. Am I audible? Lakshmi. So today I am going to start a very basic chapter of the 11th class. In the and the name of chapter is atomic structure, right? So today I am going to start atomic structure, beta. The name of chapter is atomic structure. Atomic structure, right? So in this chapter, basically we have to cover type. We have to cover all the question according to typing wise, right? The question basically asked in the NEET exam, we have to cover in this way: type 1, type 2, type 3, type 4, right? Good afternoon, beta. Good afternoon. Shubhi beta, good afternoon. Baby beta, good afternoon. How are you? So this is our first class, right? And in this class, I'm going to start a very basic chapter, that is atomic structure, right? So Kavin beta, good afternoon. Good afternoon, good afternoon. Okay. So we have to start atomic structure in a very unique way, and that the way is typing wise, right? So the question asked in the NEET exam, typing wise, type 1, type 2, like that. So can I start, beta? Are you ready, guys? Are you ready? Okay, okay, okay. Okay, very good, very good, very good. Mimilisha, good afternoon, beta, good afternoon. Vedanta Lakshmi, beta, good afternoon. Okay. So how's the Joes? Okay, that is a pet line of our class, right? Okay. So see, in atomic structure, basically we have divided all the question according to topic wise, right? So first type, I have taken first type, basically related to what? Type 1 question in atomic structure. I have taken from what? Some basic thing, basically discovery of subatomic particle. So type 1 question is basically based on what? Based on subatomic particle, right? So this is based on subatomic particle. Subatomic particle, right? So this type 1 question is basically based on subatomic particle. And in subatomic particle, we have to only discuss electron, proton, and neutron, right? So we have to discuss only 3. First one is about electron, and second one thing about the proton, and third thing is about the neutron. So one question generally came from this, from the discovery of electron, proton, and a neutron, right? One question came from this, from the discovery of electron, proton, and neutron, right, beta? So first thing, which type of question is basically asked from the discovery of subatomic particle? So I am going to tell you. So see in the next page. So in this type, first question is basically came on what? E by m value of subatomic particle. First question is came in on what? E by m value. E by m value of what? Of they can say for what? Cathode rays, right? And they can also say for what? Anode rays, right, beta? Right. So they can ask E by m value for cathode rays and for anode rays. And all of you know cathode rays are what? Stream of electron. Basically cathode rays means what? Electron. And anode rays basically means what? Proton, right? And anode rays are also called as canal rays, right? All of you know, right, beta? They are also called as canal rays, or sometimes they are called what? Anode rays, right? And they are also called proton. So is it okay to all? Cathode rays also called as electron, and anode rays also called as proton or canal rays, right? So the E by M value, basically what do you mean by the E by M value? E is basically charged on particular ray and M is the mass of that particular ray. So basically they ask the E by M value of cathode rays is depend on the nature of gas or not depend on the nature of the gas. And in the same way they can also ask the E by M value of the anode rays or canal rays depend on the nature of gas or not depend on the nature of the gas. So anyone can tell. So if I'm asking here, see, the E by M value, the E by M value, so E by M value of cathode rays is depend or not depend on the nature of gas, So the E by M value of cathode rays depend on the nature of gas or not depend on the nature of gas. So all of you know, please reply in the chat box. So the E by M value of cathode rays does not depend on the nature of gas. Whatever gas you have taken in a discharge tube, the electron is same, right? If you have to take, for example, if you have to take nitrogen gas is there, right? So in this case, and nitrogen ionized like that, and it give like this one. And if you take, for example, O2 gas, so O2 ionizes like that, O2 1 positive, and it give what? Minus. So this minus species is basically called what? Cathode rays. And this entity does not depend on the nature of gas, because all of you have to see there's a -1 charge and the mass of electron is remain the same, right? In all the cases, whatever the gas you have taken, in all the cases, the mass of electron is still remain the same and the charge is always taken as 1. So the E by M value of the cathode rays does not depend on the nature of gas. And in the same way, you see here, this part, basically this positive part is called what? Anode rays, right? Basically positive part is basically anode rays, right? In that case, the E by M value of anode rays depend on nature of gas. Depend on nature of gas taken inside the tube. Nature of gas taken inside the tube, right? So all of you getting this way? Taken in tube. So ultimately we are concluding this thing. The E by M value of cathode rays does not depend on the nature of gas, and the E by M value of the anode rays depend on the nature of gas taken inside the discharge tube, right? And the second most important question came from the discovery of subatomic particle is what is the source of cathode rays? The source of cathode rays is what? Basically gas taken inside the tube and the electrode metal, right? But in case of anode rays or canal rays, what is the source of cathode rays or canal rays or anode rays? That is the gas, only gas taken inside the tube. So mainly these two type of questions are asked from discovery of subatomic particle. First thing, E by M value comparison, and second thing, source. And sometimes the third type of question is also asked from the discovery of subatomic particle. In the discovery of subatomic particle, how we take high voltage and how we take very low pressure. What is the reason for taking very high voltage, and what is the reason for taking very low pressure? So the answer for that question is why we are taking very high voltage, because the ionization energy of gases are very high. So to ionize the gases, we require very high voltage. So in this case, we have to take the voltage in the range of 10,000 volt, right? And the second question arises, that is why we have to take very low pressure in the discovery of basically cathode or anode rays inside the discharge tube. So the reason is that taking the very low pressure because the gases are non-conducting, right? So to make the gases conducting in nature, we have to take a very low pressure, because at low pressure the gases became conducting, right? Okay, so that these things is basically asked from a NEET exam from discovery of subatomic particles. So this is okay to all, please reply beta. This is okay. Please reply in the chat box. Tell beta, tell. So this thing is okay. Basically, I have started this series to consider the typing of question in a particular chapter, basically which are going to be asked in a NEET exam as well as in a school. So this is okay. Reply in the chat box. Subbu beta, Lakshmi, Mimi beta, this is okay. So can I move forward? Very good, very good. So we have to take the some question. For example, an element having the atomic number 25 and the mass number is 55 will have. So atomic number is given, that is 25, and the mass number is 55, and they ask how many proton and how many neutron is there, right? So how to calculate here? So all of you know, for any neutral species, for any neutral atom, beta, for any neutral atom, number of electrons is equal to number of proton, and that is equal to atomic number Z, right? And the second formula is also valid. Mass number A is equal to number of proton plus number of neutron. So always use these two formula to calculate number of electron, proton or neutron in any nucleus, right? So see here, the atomic number is given as, Z is given as 25, and the mass number A is given as 55. So you have to calculate how many number of protons. So number of proton is equal to Z, and that is equal to 25, right? And how many number of neutrons? So you use the formula A is equal to P plus N, right? So here N is equal to what? A minus P is there. So A is what? A is here mass number, and mass number is 55, and the number of proton is 25. So the answer come to be 550, and this 5 to 2, this is 30. So 30 neutron are there, 30 neutron and 25 proton. So option A is right. So are you able to do the question? Not dependent. Okay, Gandhi beta, good. So are you getting this question beta? Are you comfortable with this question? Yes, very good. So now we have to take the next question, right? See the E by M ratio for canal rays. Do you know canal rays? Canal rays is also called as what? Basically, these are anode rays, right? Anode rays. Otherwise, you can say these are the stream of proton, right? So the E by M value for the canal rays, first option is varies with the element forming the anode in the discharge tube. That's not right. And the second option given as varies with the gas in the discharge tube. C, varies with the gas in the discharge tube, right? And the second thing is constant, not right. Both A and B are correct. So which one is correct? Only this one. Varies with the gas taken inside the tube, right? Okay, very good. Now next question. The number of proton, neutron and electron in 71 Lu 175 respectively. So simply use the formula what for any neutral species, for any neutral atom, number of electron is equal to number of proton is equal to atomic number, right? So in this way, this species, because here see 71 Lu, this is 175. So representation of any atom is like that, Z, and this is an element, and here is written as A. So if this is a what, this number is what, atomic number here, right? Atomic number. So this is what, atomic number here, atomic number here, right beta? And this number represent what, mass number A, right? So comparing the standard representation of any element, we can say this is the atomic number and this is a mass number. And all of you know, for any neutral atom, atomic number is equal to number of proton and that is equal to number of electron. So here, this is equal to what? 71. So number of electron is equal to number of proton and that is equal to atomic number. These are 71 in this species, in this element. And now you have to calculate how many number of neutron, because they ask number of proton, number of neutron and electrons. So electron and proton are same. Now you have to calculate number of neutron. How to calculate beta? Number of neutron using the formula. What is the formula here? A minus what? A minus P, where mass number is 175, right? And number of proton is, how many number of proton are there? 71. So what is the value? 5 5 separated by 1, this is 4, and 7 this is 0, and 1. So 104. So how many number of electron, proton and neutron? 71, 71 and 104. So option C is right. So is it okay to all? Please reply beta. It is okay. Very good. So C. Okay. Now let us take next question. Which of the following are affected by the electric field? So anode rays or cathode rays are both A and B. So all of you know anode rays contain the what? Positive charge, right? And cathode rays contain the negative charge, right? So if we pass the electric field and any species which contains charge, positive or negative, that will affected in the presence of electric field, right? So the answer is both A and B, right? The next question. Millikan oil drop experiment is used to find what? Tell me. Millikan oil, it is a very, very important experiment, basically, which take part in the discovery of subatomic particle, right? So Millikan oil drop experiment is used to find what? That is what? Mass of electron. And also it is used to calculate the charge on electron, but that is a secondary application, right? So now we have to take next question. So all these questions are basically based on what? Discovery of subatomic particle, right beta? Discovery of subatomic particle. Once beta, how are you? So all these are based on discoveries of subatomic particle. Now we have to take type 2 question. So type 1 question is okay to all, please reply. Type 1 is okay. Type 1 of the atomic structure is okay to all. And type 1 question is basically based on discovery of subatomic particle, right? Now type 2, what are the type 2 question? Type 2 question in structure of atom came from some important term. This type 2 question came from some important term, right? So this question, it is based on some important term, some important terms, right? What are the some important term? You know, isotopes, isotope, right? Second one is a isobar, right? And third one is a isotone, and fourth one is a isoelectronic, right beta? And fifth one is based on iso start, and Sixth is isodiapher. Isodiapher, right? So basically type 2 question, and that is a very high probability to come this type of question in the NEET exam. Very high. What happened? Okay, Vance, very good, very good, very good. Okay, so all of you getting these terms? All of you aware with these terms? Isotope, isobar, isotone, isoelectronic, isostat, and isodiapher. Please reply in the chat box. Otherwise, first I will revise this term and then I will take the question, right? One question must came in NEET exam. One question must came in the NEET exam from this topic, from this typing. Must. And it is very easy to solve, right? If you know what is isotope, what is isobar, what is isodiapher, what is isostat, right? So, okay. So first I'm going to quick revise to these terms and then I will take the question, right? Okay, see beta. See, first thing, what is isotopes? The two are more than two atoms, two are more than two atoms of the same element, which have the what? Same atomic number but different mass number are called as what? Isotope. All of you know, right? Nothing, beta, nothing. Yes, right? So isotope is okay to all. Please reply. Isotope is okay. For example, C6, C12, and 6C13 and 6C14. All these are the isotope of carbon, right? In all, the atomic number is same, 6, 6, and 6, but mass number is different. In one, there's a 12 mass number. In the next 13 and the next 14 is there, right? Okay. And one more example of the isotope is 17Cl35, 17Cl37, right? These two, atomic number is same, but mass number is different. So they are also isotope of the chlorine, right? In the same way, you can also see in case of hydrogen, right? So are you getting what are isotopes? Very good. Now second point, second term, isobar. What are isobar, beta? Two are more than two atoms of the different element, which have the what? Same mass number but different atomic number, right? So all of you know, right? So the atom with the same mass number but different atomic number is called what? Isobar. For example, 6C12 and 7N14. In these two, atomic number is 6, right? And here 7, but mass number is 14 and 14. So 6C14 and 7N14 are the example of what? Isobar, right? Very good. Very good, beta, very good. Now see the other term, isotones. So what are isotones? The two are more than two atoms which have the what? Same number of neutron, right? The number of atom or nuclei with the same number of neutron are called what? Isotones. Isotone. Iso means same, tone means neutron, which have the same number of neutron, right? So see here, 6C14 and 7N15. So if in this you have to calculate how many number of neutron. In this case, number of neutron is equal to 14 minus 6, right? So this is 8, right? And in this, how many number of neutron are there? So 15 minus 7. So that is also 8. So in both element, same number of neutron are there. So these are called as what? Isotones, right? Right, Ashitha beta. So are you getting, Ashitha beta, isotones? Are you getting isotone, isotope, and isobar? Right. Okay. Now next term is isoelectronic species. So what are isoelectronic species? The species which contain same number of electron, right? And in these they also contain cation or anion or simple neutral element, right? Okay. So species with the same number of electron. For example, I have taken O2 minus, F minus, Ne is there, and Na1 positive is there, and Mg2 positive is there, right, beta? So if you calculate number of electron in each case, so in this case, how many number of electron? Atomic number of oxygen is 8, and there's minus 2 charges there. So total electron is 8 plus 2, that is 10. In this case, 9 plus 1, that is 10 electron. In this case, 10. In this case, 11 minus 1, this is 10 electron. In this case, 12 minus 2, that is 10 electron. So all these species are called what? Isoelectronic, right? So these 4 terms are clear to all. Please reply in the chat box. Ashyutha beta, is it okay? Ashyutha once. Okay, very good. So now we have to take 2 more terms, and then we will do the question, right, related to type 2. Okay beta. See, now this term isodiapher. What is isodiapher beta? Isodeapher. Iso means same. Da means difference, right? Means the species are the element in which the difference of what? Difference of what? Neutron to proton is same, right? N minus p value is same. So isodiapher are the set of nuclei that have the different number of proton and a neutron, but there is the same difference of what? Difference of the neutron and a proton. Basically, isodiapher are the species which have same value of n minus p, where n is the number of neutrons, beta, and p is the number of protons. P is number of protons, right? So the species in which the n by p value is same is called what? Isodiapher. For example, I am taking 90 thorium 234. I am taking what? 90 thorium 234, and another element I have taken 90 uranium 238, right? So in this case, if you have to calculate n minus p value, right? So what is the n minus p value here? How many number of electron in this case? Anyone can tell? How many number of electron in this case? That is 90, right? Okay, and number of proton is also 90. And how many number of neutron in this case? 234 minus 90, right? This is the number of neutron. And how many number of proton? That is 90, right? So minus 90. So what is the n by p value? N by p value is 234 minus 180. So if you subtract this, you got 4 and 3, 13. From 13, you subtract 8, you got what? 5. So 54 is there, right? 54 is there. And if in this element you have to calculate n minus p value, then you got what? 238 minus 92 minus 92, then you got what? You got 54. So in these 2 elements, the n minus p value is same, so they are called isodiapher. So isodiapher is okay to all, please reply. Isodiapher is okay. So now last some important term of the atomic structure is isostat. So what are isostats? So isostat are basically the entities are the species which have the same number of atom and also have the same number of electron. So the species which satisfy these 2 conditions. First condition is contain the same number of electron, and second condition is same number of atoms. So isostat are those species which contain same number of atoms, right? And also contain same number of electron. So if any species follow these 2 conditions simultaneously, then those are called isostat, right? Follow simultaneously same number of electron and same number of atom, right? So for example, here I have taken N2 and Cu. So Cn2 and Cu, In N2, how many number of atoms? 2, right? In CO, how many number of atoms? 2, right? So now you have to calculate number of electron in N2. So number of electron in N2 is what? 7 2s are 14. 14 electron is there. And in CO, how many electron? 6 from carbon, in 8 from the oxygen. So 8 plus 6, that is a 14 electron also in CO, right? So CO also there's a 14 electron. So CO and N2 have the same number of atom and same number of electron. So they are called isoster to each other, right? So are you getting these some important term? So just I am recalling again, just there's I'm going to quick recap. Isotope are those which have the what same number of atom, right, but different mass number. Isobars are those which have the same mass number but different atomic number, right? And in isotone, which have the same number of neutron. Isoelectronic, which have the same number. Isotone, which have the same number of neutron. And isoelectronic are those which have the same number of electrons, right, beta? And in isodeapher, those which have the same value of n of what n minus p, where n is the number of neutron, p is the number of proton, right? And what are the isoster? Same number of atom and same number of electrons. So are you getting? So now it's a time to take a question, right? Okay, see. Now the question number 1 is there. Be2 positive is isoelectronic with which of the following ions? Solve it. Solve. Take the question. Be2 positive. So first you have to calculate number of electron in Be2 positive, right? Be2 positive. How many, what is the atomic number of Be? That is a 4, right? That is a 4. And there's a 2 positive is there, so minus 2. So number of electron is what? Number of electrons in Be2 positive is equal to what? 2, right? So the species which contain 2 electron are called what? Isoelectronic. So in hydrogen, H positive, 0 electron is there. In Li1 positive, there's a 2 electron because atomic number is 3. 3 minus 1, that is equal to 2 electron is here. In this case, how many electron? 10 electron. In this case, how many electron? 10 electron is there. So this is isoelectronic with Be2 positive. So all of you getting? Please reply in the chat box. All of you getting? Very good, very good. Ashita, Bhatni beta, very good. B, yes, B is right. Very good. So can I take one more question? Okay. So this is okay to all, please reply. The next question is, isoelectronic species are, right? So you have to find out of A, B, C and D, which of the following contain isoelectronic species? Right? Tell me. So first I have to check in option A, right? So how many number of electron in CO? This is 8 plus 6, that is 14 electron, right, beta? In CN, 6 plus 7, 13, that is minus 1. This is also 14 electron, right? In NO1 positive, how many electron? Nitrogen contains 7, right? Oxygen contains 8, and this is plus 1, so this is minus 1. This is also contain 14, right? And C2 2 minus. The atomic number of carbon is 6, and there are 2 carbon, so 2 into 6, and there's a minus 2, so plus 2. So this is what? Again 14. So option A is right. In option A, you see all the species have the same number of electrons. So this represents the pair of what? The basically combination of what? Isoelectronic species. Benny beta, I don't know actually. Okay. So Benny, are you getting these questions basically, which are most important from the atomic structure? Are you getting? Okay. So now you have to solve this question. The ion that is isoelectronic with carbon monoxide. The ion which is isoelectronic with carbon monoxide. CO is there. So out of these, which one is isoelectronic? So first you have to calculate number of electron in CO. How many number of electron in CO? This is in carbon, this is 6. In oxygen, this is what? 8. 8 plus 6, this is a 14 electron, right? So you have to find that species which contain 14 electron. So now tell. Very good, beta. Bharti beta, very good. Bharti, Ashita, very good, well done. So if you have to check in CN1 minus, so in C this is 6, in nitrogen this is a 7, and this is -1, this is a +1. So there's a 14 electron in there. So option A is right. Very good, beta. Benny beta, please answer. Yes, Benny. Bharti, Ashita, once, very good, well done. Well done, Lakshmi beta, well done, very good. So all of you doing very well, very good. So ultimately, we are going to do a very blast type thing basically. So I have to revise each and every chapter of 11th class basically in a typing wise manner. So it is very easy to revise the chapter with the help of question. Right? With the help of question. How to revise the chapter with the help of question? If you are facing issue in the question, then again go back to the theory part and then again go back to the question part. So that this way of doing the practice very important. Right? So all of you getting? Now I have to take next question. So see beta. Okay. So these type 2 question are okay. In type 1 question, I have already taken. So I am just concluding here. In type 1 question, in this chapter, I have already taken based on subatomic particle, right? I have already taken subatomic particles, right? And in type 2 question, I have taken based on isotope, isobar, isotrope, isobar, etc. Basically these 6 terms. So these 2 type is covered right now. Right? So now what is the third type question asked in the this chapter, asked from this chapter? So third type of question is what? This is third type question. In type 3 question, they basically ask question from Bohr atomic model. From Bohr atomic model, right? They ask the question from Bohr atomic model, right beta? They ask the question from Bohr atomic model. Basically from Bohr atomic model, from which concept they ask the question. So first I am giving you the idea from which part or from which quantity they ask the question. So see. So this is third type question. In type third question beta, in type third question, they always ask question related to Bohr atomic model. Bohr atomic model, right beta? In Bohr atomic model, they basically ask first type. In the type 3, we have divided into subtypes, right? So from Bohr atomic model, first type question is to calculate radius of electron present in nth orbit, right? Present in nth orbit. So first type of question is asked from Bohr atomic model is to calculate the radius of electron present in nth orbit. And first you have to remember one most important thing from the start before starting the type 1 question. Bohr atomic model is only applicable for one electron species. Only applicable applicable for one electron species. It is only applicable for one electron species. Must remember this thing. So you can only apply all the formula Bohr atomic model only those species which contain one electron, right? Only those species which contain one electron. For example, hydrogen is there. For example, He1 positive is there. For example, Li2 positive is there. For example, B3 positive is there. etc. Right, beta? So you can use all the formula of Bohr atomic model only for those elements which contain only one electron, right? Yes, Benny beta. Okay, good. Mahadev Prasad, how are you, beta? So can I take the one question basically based on what to calculate the radius of electron present in nth orbit? So what is the formula to calculate the radius of electron present in nth orbit according to Bohr? So the formula is R is equal to 0.529 n square by z. And you also derive this formula, but there is no need right now because in this series basically we are doing what? Typing wise question. This practice of chapter with the help of question, and we go to the theory with the help of question, right? So that is the main highlight of this series, right? So all of you know this formula, R is equal to 0.529 n square by z, and the unit is saying strong here, right? So you can also write R is proportional to what? N square by z. And here, what is n? N is orbit number. N is orbit number. And z is what? Atomic number, beta, right? Z is atomic number. So if I am taking the question related to this, so see, can I take one example? Okay, beta. So I am going to take one example. For example, I am saying calculate the radius of electron in each case, right? Now first case is for hydrogen atom present in second orbit. The electron present in second orbit. In that case, you have to calculate what is the radius of hydrogen, right? Basically, the electron present in second orbit. And then the B part for He1 positive and the electron present in third orbit, right? Electron present in third orbit. And in the C part, I have taken for Li2 positive, the electron is present in what? Second orbit. So you have to calculate the radius in each case, right? So how to calculate the radius? So see beta, how to apply the formula basically. So simply we know what radius is equal to 0.529 n square by z, and just put the value, and here this angstrom is there, right? So for hydrogen atom, what is the value of z? Z is 1, and second orbit means what? N value is 2. So you just put the value of z and n in this formula. So this is 0.529, n is what? N is 2, so 2 ka square and divide by z, that is 1. So what is the value here? 4 multiply 0.529 angstrom. So this is the answer. Is it okay to all? Please reply, beta. Is it okay to all? Please reply. Yes, very good. So now how to calculate the radius of this? So simply use the same formula. R is equal to what? 0.529 n square by z, right? So here for He1 positive, what is the z value? What is the atomic number of helium? This is 2. And this is third orbit, so n is equal to 3, right? So put these values here. 0.529 n means what? 3 here. 3 square divided by what? Divide by 2. So what is the value coming to be? 0.529, this is 9 divided by 2, right? So this angstrom coming to the answer. So in case of Li2 positive, how to calculate beta? In case of Li2 positive, use this. R is equal to, again use the same thing, 0.529 n square by z, right? And in this case, what is the value of z here? The value of z here is 3. And what is the value of n here? N is 2. This is given in the question. So just put the values, 0.529 multiply n, n is 2. So 2k square divided by what? This is 3. So this is the answer. You must solve these values, right? So today's class is over, right? So in today's session, I have already taken type 1 question, type 2 question, and type 3 question, which are basically related to the what? Atomic structure. And in this regard, these type of question are asked in your NEET exam. So bye bye all, and thank you so much. We will meet in the next class. My next class in Saturday, I think, right? And in the Saturday class, I will take the remaining part of the what Bohr atomic model, and then I will take the question related to the what Heisenberg basically uncertainty principle, and then de Broglie hypothesis, because one question almost come from the de Broglie hypothesis, and one question always come from the what Heisenberg uncertainty principle, and then one question from the what Schrodinger wave equation. So bye bye all. Thank you so much. We'll meet in the next class. Right. Bye.